Today we'll be talking about diethylformamide. Diethylformamide is a simple monocarboxylic acid amine, which basically means that the double bonded O and the nitrogen form a carboxylic acid amine. Diethylformamide is commonly shortened to DMF, and its molecular formula is C3H5H7NO. And the molecular formula is 101.1. This is gotten by taking the AMUs of each atom in the structure. So carbon, you have 5 of them, you would multiply that by 12.01, and with hydrogen, you have 11 of them, you'd multiply that by 1.008, and then for nitrogen, you would do 14, and oxygen 16, and then you would add all of them up. And that's how you get 101.1. Your degrees of unsaturation are given by your pi bond with your carbon and your oxygen bond. They're double bonded together, which is your degree of unsaturation. And you have 17 sigma bonds. So these are the singular bonded atoms together. So your singularly bonded hydrogen to your nitrogen, your singularly bonded carbons, and then so on. You have a tertiary amide. The blue atom is represented by the nitrogen, so this atom will have 3 different bonds to it with carbon atoms, so that's what makes it tertiary. If it was secondary, it'd only have 2. If it was primary, it'd only have 1 bond. The boiling point is 176 to 177, and its physical state is a yellowish liquid. It's commonly used in factories handling polyurethane materials and acrylic fibers, and the NN in the starting of the name represents the 2 methyl groups that come off the nitrogen, so the CH3s. You have 5 unique carbons, so all of the carbons in the molecule are unique, and this just means that each carbon isn't like the other one, so they could have different bonds connecting them together or different molecular geometries. It just depends. Your unique hydrogen sets, all of them are unique again because your carbons are unique, and then your uniqueness set is 5,5,3,3,2,2,1. So for your hydrogens, the 2 3s would be obviously the methyl groups, and then the 2s would be the ones directly off of the nitrogen, and then your 1 would be the carbon bonded to the O. You have 4 sp3 hybridized carbons. These are all the carbons that are not attached to the oxygen because that one is sp2 hybridized. This is because the carbon has a double bond to the O. And then, of course, your classifications of your carbons, you have 2 CH3 carbons, the methyl groups coming off of the ethyl group from the amide. And then you have 2 CH2, which are the carbons directly attached to the methyl groups. And then your CH group is what's attached to the amide and your oxygen group. So when building the molecule, your blue Snatom will be your nitrogen, and then the red Snatom will be the oxygen. The black Snatom, of course, would be the carbon. The white would be the hydrogen. So when we're building this, we're going to start with the atom that's attached to the oxygen. So the little gray Snatoms represent a double bond. So since the carbon is double bonded to the O, we're going to have 2 of the gray Snatoms, and you're just going to put them together like that. This represents the double bond between the carbon and the oxygen. Of course, we have a hydrogen coming off of the carbon because it needs 4 bonds, and then this carbon is directly attached to the nitrogen group. Now, attached to the nitrogen group is 2 ethyl groups. So these would be the start of your ethyl group, and then now our nitrogen has 3 bonds, which again makes it a tertiary amide. So with these 2 groups, we're going to have 2 hydrogens on them because each carbon wants 4 bonds, and then we're going to attach our methyl groups. So our methyl groups are going to have 3 hydrogens, and then our second methyl group is going to be attached here with 3 hydrogens, like this. And this represents the molecule diethylformamide.